Welcome to The Deep Dive, where we take a stack of fascinating sources and extract the most important nuggets of knowledge, giving you a shortcut to being truly well-informed. Today, we're diving into a topic that touches nearly every corner of our planet: urban expansion.
Right.
For many, this brings to mind, concrete jungles relentlessly consuming green fields. But this deep dive into a rapidly changing region asks a crucial question. Is that the whole story?
That's a great question.
Can a place grappling with immense growth also find pathways to preserve its vital green spaces?
Absolutely. Our source material for this deep dive is a comprehensive spatiotemporal analysis.
Okay, spatiotemporal, so space and time, right?
Exactly. It looks at how things change, not just over time, but specifically where they change on the map. This study from Akadlor Transactions on Geosciences focuses on the Narayanganj district in Bangladesh. And it uses Integrated Geographic Information System, or GIS, and remote sensing techniques over a 20-year period from 2003 to 2023.
20 years, that's a good stretch.
It is. Our mission here is to unpack how urbanization in this critical area has impacted agricultural land and vegetation health.
And what that means for the environment and, well, the people living there.
Precisely.
Okay, let's break this down. So we're talking about looking at satellite images spanning 2 decades to see exactly how land use has shifted. It's like having a time lapse for the landscape almost.
That's a good way to put it.
And what they found reveals, well, some incredibly nuanced patterns, kind of challenging common assumptions.
Yeah.
And even offering some surprising glimmers of hope.
To set the scene for you, Narayanganj district is strategically significant. It's part of the larger Dhaka metropolitan region in Bangladesh.
Right, near the capital.
A major industrial and economic hub, so much so that it's known as the Dundee of the East.
Dundee of the East, okay, like the Scottish industrial city.
Yeah, exactly. A nod to its historical industrial power.
And when you look at its characteristics, it sounds like a real pressure cooker.
It is.
I mean, the 2011 census had a population density of nearly 3,900 people per square kilometer.
That's incredibly dense.
Almost like squeezing a small city into every square mile.
Yeah.
You can just imagine the land pressure that creates.
Absolutely.
But here's the kicker. It also has these incredibly fertile alluvial soils.
Right, those rich river-deposited soils.
Historically vital for agriculture, producing everything from rice and jute to vegetables and fruits.
So you have this intense competition for land.
Exactly. What's truly compelling here is how that location, being an industrial powerhouse near Dhaka, coupled with rapid industrialization and population growth, has put immense pressure on land use.
Which makes Narayanganj such a compelling case study, doesn't it, to understand that balance?
Yeah, balance between development and environmental preservation.
So how do researchers actually track these massive shifts across the landscape?
Right.
The study uses something called land use and land cover, or LULC classification.
LULC, okay.
Think of it as basically categorizing every piece of land into different types: built-up areas, green spaces, barren land, and water bodies.
Had simple categories.
And the overall shifts over these 2 decades, 2003 to 2023, they're quite telling.
So what did they find? Big changes.
We saw a notable increase in built-up areas, expanding by over 5% of the total land area.
5% increase in concrete, basically.
Essentially, yeah. Meanwhile, agricultural land experienced a more modest net decline of about 1.6%.
Only 1.6% decline over 20 years.
Yeah.
That sounds surprisingly low, actually, given the pressure.
Well, what's truly insightful here is that it's not a simple story of continuous loss for agriculture.
Okay.
That agricultural land figure didn't just continuously shrink. It actually showed signs of partial recovery after an initial steeper decline in the first decade.
Really? So it bounced back a bit?
It did, which immediately raises the question, what factors might have contributed to that rebound?
Yeah, like policy or farmers adapting or something else.
Could be any number of things. But that hint of resilience, it challenges the common narrative that urban growth just means irreversible agricultural decline.
Interesting. What about the other categories? Barren land and water?
Barren land saw a substantial net loss of over 7%.
Okay, so that land went somewhere else.
Suggesting it was largely converted to other uses, likely built up or maybe even some agricultural.
Right.
Water bodies, surprisingly, saw a net gain of over 3%.
A gain in water? How does that happen?
Well, it fluctuated significantly. They expanded quite a bit by 2013, then declined again by 2023. So it points to complex dynamics, maybe seasonal changes, maybe human interventions like land reclamation shifting things around.
Okay, so we've got the overall shifts, But, for anyone looking at a map, the crucial question is, where exactly is this urban growth happening? Is it spreading out evenly, or are certain areas just getting hammered? And what does that mean for planning?
That's a key finding. The study highlights a clear spatial asymmetry.
Meaning it wasn't even...
Not at all. The growth was definitely not uniform across the district.
This is where that spatial analysis really shows its worth, I guess.
Exactly. The hot zones for expansion were overwhelmingly in the northwestern and northern sectors.
The northwest and north, okay.
The study specifically notes that built-up areas in the northwest surged significantly. For instance, their measure of built-up density there climbed beyond 60 units by 2023.
Wow, concentrated growth.
Very much so.
Yeah.
And that dominant spatial orientation is likely influenced by, things like proximity to major highways, river ports, existing industrial clusters.
Makes sense. Infrastructure pulls development.
Right. In contrast to the eastern, southeastern, and northeastern directions, they showed comparatively limited urban expansion.
So a very uneven picture.
It really underscores the critical importance of spatially informed urban planning. You need to know where to plan and why.
Okay, let's drill down to the direct impact on agricultural land, which is such a vital resource. How much of it was actually, swallowed up by development over those 2 decades?
The conversion rates are indeed significant. Between 2003 and 2013, just the first decade, over 15% of agricultural land, about 122 square kilometers, was transformed into urban areas.
15% in 10 years. That's substantial.
It is. And over the full 20-year period from 2003 to 2023, that figure rose to over 18%.
18% total. So nearly 145 square kilometers.
That's right. A large chunk of farmland becoming built-up land.
So we've seen significant conversion. Is this just an inevitable march? Or did the study find any indication that this trend might be maybe slowing down, changing course?
That's a crucial signal they picked up on. The rate of conversion to built-up areas was actually slightly lower in the second decade.
Oh, interesting.
About 14.7% from 2013 to 2023 compared to that higher rate earlier.
So maybe a hint of stabilization?
It hints at potential stabilization, yeah. In the rate of urban expansion consuming agricultural land. Other conversions, like to water bodies, actually decreased significantly in the second decade, and conversion to barren land stayed minimal.
And despite these conversions, you mentioned resilience earlier. Did the study find that some farmland just held on?
Exactly. A significant percentage of agricultural land, nearly 28%,
Almost a third.
actually remained unchanged over the whole 2 decades.
Wow.
Which indicates, as the study puts it, a positive trend in preserving agricultural areas.
So maybe policy worked, or better land management.
It suggests potential resilience, yes, due to factors like maybe policy interventions, improved land management, or even socioeconomic factors making farming viable. It definitely challenges the idea that all agricultural land near cities is doomed.
Okay, so that covers the land area itself. But the study also looked at something less visible, but maybe just as critical: vegetation health. How do you even measure that from space?
They use specific vegetation indices derived from the satellite imagery.
Right.
The first is NDVI. That's the Normalized Difference Vegetation Index.
NDVI, okay. What's that tell you?
Think of it basically as measuring how green and healthy the vegetation is, sort of a health meter for plants from above.
Simple and effective. And the others?
The second is SAVI, the Soil Adjusted Vegetation Index. It's similar to NDVI, but it helps account for the influence of soil brightness, especially important in areas where vegetation might be sparse.
Got it. Adjust for the background.
And finally, NDBI, the Normalized Difference Built-Up Index. This one's used specifically to detect and map built-up areas themselves.
Okay, so you've got measures for greenness, adjusted greenness, and buildings. So what do these indices tell us about the district's overall greenness? How did it change over time?
Well, there was a consistent downward trend in vegetation health overall.
A decline. Not surprising, maybe.
No, but quantifiable. In 2003, large rural areas showed high NDVI values indicating dense, healthy vegetation.
Right.
But by 2023, much of the district's NDVI values fell into the low range, particularly near those expanding urban centers we talked about.
So less green near the new developments.
Exactly. And the mean SIV also dropped drastically, from levels you'd expect in healthy croplands, around 0.38 in 2003. Down to around 0.06 by 2013, especially near industrial and residential zones, a really sharp drop.
So, if I'm understanding correctly, the data paints a very clear picture here. As urban areas expand, The natural greenness of the landscape is systematically declining. Is that the direct takeaway?
That's precisely what the data showed. They found a statistically significant inverse correlation between NDVI, the built-up index, and both NDVI and SIV, the vegetation indices.
Inverse correlation. So basically, more buildings, less green stuff.
Pretty much, yeah. As built-up areas increased, vegetation health measurably declined.
And this isn't just about looking less pretty, right? There are real ecological consequences.
Absolutely. This isn't just a visual observation, it's a quantifiable ecological consequence. It points to serious issues like land sealing, paving over soil.
Right, water can't soak in.
Exactly. Yeah. Habitat fragmentation, breaking up natural areas, and the loss of critical ecosystem services.
Like what kind of services?
Things like carbon sequestration, microclimate regulation, think urban heat islands, and maintaining soil fertility, all impacted.
Okay, so given this complex dance development versus nature, what path forward does the study suggest? How do you balance rapid urban expansion with preserving the ecology?
The study offers several key recommendations, really focusing on proactive planning.
Makes sense.
First, integrating green infrastructure into urban planning.
Green infrastructure like what? Parks and green roofs?
Yeah, things like urban green belts, rooftop gardens, even protecting or creating peri-urban agricultural zones right on the edge of the city.
Okay, what else?
Second, implementing strict spatial zoning restrictions.
So deciding up front where building can't happen.
Exactly, to protect high-value agricultural land like those resilient areas we discussed and ecologically sensitive zones.
That seems crucial for preserving that resilience.
Absolutely. Third, utilizing smart monitoring, using these same GIS and remote sensing systems.
The tools they used for the study.
Right. Use them for real-time assessment and proactive land use planning, not just looking backwards.
Keeping an eye on things as they happen.
Fourth, encouraging compact city models. Think building up, not just out. Vertical urban expansion to reduce the spatial footprint.
Less sprawl.
Less sprawl.
Yeah.
And finally, building local support and capacity. Helping stakeholders, farmers through education, incentives, sustainable agricultural technologies.
Getting everyone on board.
It really calls for a truly holistic, multi-sectoral approach. You have to harmonize the urban development goals with environmental stewardship. They can't be treated as separate issues.
That makes a lot of sense.
And, while this study provides strong empirical evidence, it's grounded in geography.
Yeah.
It's also important to acknowledge its limitations, like any study.
Sure. What were they?
Well, for example, relying solely on satellite data means it might not fully capture all the complex socioeconomic drivers behind land changes.
Right, the why behind the what.
Exactly. And the decadal time steps might miss finer seasonal fluctuations. Plus, it didn't include ground-based biophysical data, which could offer even deeper insights.
So good data, but always room for more detail.
Precisely. It just means it's an ongoing area of research, always ripe for deeper exploration.
So what does this all mean for you, listening? This deep dive into Narayangand shows us that urban expansion isn't just some simple, unstoppable force that uniformly destroys all green space.
Mm-hmm.
It's a complex dance, isn't it, between development and nature, where policy and human choices can actually make a difference.
They really can.
Leading to these partial recoveries and even resilience in some agricultural areas, which was quite surprising.
That's right. And this research highlights that the inverse relationship between built-up areas and vegetation health, it's real. It's measurable.
You can see it in the data.
You can. And it raises, I think, an important question for all of us. If strategic planning and interventions can help preserve agricultural land and mitigate environmental harm, even in such a rapidly urbanizing place like Narayangand,
Yeah.
what does this tell us about the potential for sustainable urban development in other parts of the world, including, your own backyard?
Are we doing enough? Are we actively planning for green spaces and food security as our cities grow?
Or are we just letting sprawl take its course? Something to think about.